Hello, I welcome you once again to Kenya Mathematics Classroom, and we are still looking at calculus. And we started with the differentiation, and today we are going to look at what we call the composite functions, how we can differentiate composite functions, or how to apply the chain rule to solve problems like that. So, when we say composite functions is the same as what you call the function of a function. That is function of a function. The composite function or function of a function. And we are going to use the chain rule. You'll be using the chain rule. So now, let's assume that we have y equals ax plus b exponent n. We have y equals ax plus b exponent n. So we have a function, but the function is inside the bracket. All exponents is also another function. So it's function of a function. Now, when you have problems behaving like this, how do you differentiate y with respect to x? That's what we are going to look at. Now, what is really happening is this, and we'll be applying what we call the chain rule. That's where the chain rule will come from. So what we do is, you will let u be equal to what you have in the bracket, that is ax plus b. So let u to be equal to that. Then you differentiate this u with respect to x. And when you differentiate u with respect to x, you are getting a. Take note that b is a constant, and when you differentiate a constant, you are getting 0. And when you differentiate ax, you are getting a. And I guess by now you understand that. Now, if you have ax, exponent is 1. 1 times a is a. Then you have x. When you subtract 1 from this is s exponent 0, and s exponent 0 will give you 1. 1 times a is a. That's how come we are getting the a. So you let u to be equal to the expression you have in the bracket, and that is ax plus b. Then you differentiate that u with respect to x, and that will give you a. Then you know that y will now be equal to, we are saying that u should be equal to ax plus b. So the whole of ax plus b in the bracket is now u. So it will be u exponent n. When you are done with that, you will differentiate y with respect to u. And when you differentiate y with respect to u, it's the coefficient here is 1, so n times 1 is n. Then you have u, then subtract 1 from the exponent, you have n minus 1. So from the chain rule, what we are saying is, take note that what we need is dy dx. But what we have here is du dx and dy du. So how do we get dy dx? How do we differentiate y with respect to x? Take note that this is the same as dy over something times something over dx. Because if this dy over something times something over dy dx, you see that you still have dy dx. So what do we have here? That we can have the same thing here in such a way that when this one cancels this, we are back to this. So here we have dy du already, so this is du. Then we also have du dx. So if dx is here, then what is supposed to be here is du. This is what we call the chain rule, that's all. So dy dx is equal to dy du times du dx. Now dy du is nu exponent n minus 1. So nu exponent n minus 1 times du dx. Du dx is a. And so we have a. But don't forget that we have n. We said that the u should be equal to ax plus b. So finally, wherever we see the u, we have ax plus b. Exponent n minus 1 times a. And this is n times a will give us na. Then we have ax plus b exponent n minus 1. This is going to be our dy dx. This is going to be our dy dx, and this is simple. Now I will explain to you. Take note. Let's go back to the expression. Y equals ax plus b exponent n. The rule is that when you are differentiating y with respect to x, this is function of a function, composite function. So the coefficient of the bracket here is also 1. So n times the 1 will give us n. Then we have ax plus b. How do we differentiate? When we multiply, we subtract 1. So we now subtract 1. But this time around, we multiply by the differentiation of what we have inside the bracket. So when you differentiate ax plus b, then we are getting a. Now, if you want to simplify, dy dx will now be n times a is na. Then we have ax plus b exponent n minus 1. Is this not the same as this? So that's what we are talking about. So if you are differentiating function of a function, you multiply the exponent by the coefficient of the bracket. Then you subtract 1 from the exponent, as we do for the normal differentiation. When you are done, you multiply by differentiation of what you have in the bracket. And that will be all. Now I will be taking 1 or 2 questions to explain to you so that you understand in general what we have on the board. It is something simple. And so now let's take a look at a problem and see how best we can solve that. It is very simple. Now you take your time, you can take the video back and take your time to study what is happening. So let's assume that we have y equals, we have 2x squared plus 3x exponent 4. We have to differentiate. Do you see that this one, if you want to use the normal differentiation, then you need to expand, multiply 2x squared plus 3x by itself 4 times. When you are done, then you differentiate 10 by 10, but it is tedious. So this is function of a function. So we use the general rule to do that. And the general rule, we are finding dy dx. The coefficient of the bracket is 1. So 4 times that 1 will give us 4 here. Then we have 2x squared plus 3x here. Subtract 1 from the exponent, you have 3. Times differentiate what you have in the bracket. When you differentiate 2x squared, you are getting 4x. When you differentiate 3x, you are getting 3. So this will now be dy dx will be equal to, this is 4 times, you can write this here, that is 4x plus 3. Before this your bracket, that is 2x squared plus 3x exponent 3. This is the final answer. Don't waste your time expanding this to the 3rd power and multiplying this before the 4th. That is the answer. It's accepted. And so that is how we differentiate. Now we are going to use the chain rule to see whether we will get something similar to this. And this is what we call the chain rule. And the rule is what I showed you. So that's what we are going to use to see whether we are getting the same thing. So this is differentiation of function of a function. Simple, just like that. Just multiply, the coefficient of the bracket here is 1. So 4 times 1 is 4. Then 2x squared plus 3x in the bracket. Subtract 1 from the exponent as we do. And 4 minus 1 is 3. Times, differentiate what you have in the bracket. When you differentiate 2x squared, you have 4x. When you differentiate 3x, you have 3. I guess by now you understand that. So you now multiply 4 by this before the bracket. Now, don't forget that the question was y equals, we have 2x squared plus 3x exponent 4. So to use the chain rule, we said that let u to be equal to the expression you have in the bracket. That is 2x squared plus 3x. Then you differentiate u with respect to x. When you differentiate this, this will give you 4x. When you differentiate this, you get 3. Then this will be y equals, take note that everything in the bracket is now represented by u. So this will be u exponent 4. Then we said that you differentiate dy with respect to u. Coefficient here is 1. 4 times 1 is 4. And you have u. Subtract 1 from 4, you are getting 3. So you have 4 u exponent 3. Take note that we said that the chain rule is dy dx equals dy du times du dx. And so dy dx will be equal to dy du. Dy du is 4 u exponent 3 times du dx. Du dx is 4x plus 3. That is 4x plus 3. That is du dx, 4x plus 3. So we have 4u exponent 3. We said that u should be equal to 2x squared plus 3x. So we do substitution. So instead of u, you now write 2x squared plus 3x. So you have 2x squared plus 3x. Don't forget exponent 3 times you have 4x plus 3. So in multiplying, you have 4, you can bring this here, then you have 4x plus 3 before your 2x squared plus 3x or exponent 3. Do you see that our dy dx here is the same thing we had here? That's all. So we have 4 into bracket 4x plus 3 times 2x squared plus 3x or exponent 3. So this is the chain rule. you let u to be equal to what you have in the bracket. Then you differentiate u with respect to x. Then y, you said u should be equal to 2x squared plus 3x. So wherever you see 2x squared plus 3x, you now substitute that by u. So y equals u exponent 4. Then you differentiate with respect to u, and that will give you 4u cube. You know the general rule for differentiation. Then from the chain rule, you did your substitution and your answer is coming out. So I would advise that you take your time, you look at it, because dy dx is equal to dy du, and dy du is now 4u cube. So you have 4u cube times du dx. Du dx is 4x plus 3. That's how come you have 4x plus 3. And we said that u should be equal to 2x squared plus 3x. So wherever you see u, you now substitute that by 2x squared plus 3x. And that's how come we have 4 times 2x squared plus 3x, or exponent 3 times your 4x plus 3. So you multiply this by this times this, and that is your answer. And that will be all for now on this particular episode.